Andrew Lumsden FRS FedSci, born the 22nd of January 1947, is an English neurobiologist, professor of the University of London and founder in 2000 of the Medical Research Council Centre for Developmental Neurobiology at King's College London. He is a Fellow of the Royal Society, the Academy of Medical Sciences, and King's College London, and a member of the European Molecular Biology Organisation. Andrew Lumsden attended Kingswood School, Bath, as Andrew Sita-Lumsden, and graduated from St. Catherine's College and the University of Cambridge with double first-class honours in natural sciences. After visiting Yale University for 2 years as a Fulbright Scholar, he returned to England to complete his PhD in Developmental Biology at the University of London. He has held various lectureships at Guy's Hospital Medical School and the United Medical Schools of Guy's and St. Thomas's Hospital before being made a full professor of the University of London in 1989. He has been an International Scholar of the Howard Hughes Medical Institute, 1993 to 1998, and a Miller Institute Visiting Professor at the University of California, Berkeley, 1994. Lumsden has served on the Medical Research Council Neuroscience as a Mental Health Board and Grants Committee, 1992, 1998. The Wellcome Trust Neuroscience Funding Committee, 1997, 2000, and the Brain Functions Grant Review Committee of the Human Frontier Science Program, 1998, 2001. He has also served as editor of Development, 1995, 2007, and is co-founder of the online, open-access journal Neural Development. In addition, Andrew Lumsden is a co-head of section for Faculty of 1000. Andrew Lumsden has co-authored a book entitled The Developing Brain with Michael Brown and Roger Keynes. Research. Following his PhD on epithelial mesenchymal interactions in mammalian development, Lumsden's interest moved to the question of how integumental structures, such as teeth and vibrissae, acquire their nerve supply, and how the cranial neural crest contributes to their patterning. Studies on the development of the trigeminal nerve and ganglion led on to observations of the organization of their corresponding motor and sensory regions of the central nervous system. His seminal observations and experiments on the developing hindbrain of mammal and bird embryos confirmed the long-suggested but never agreed view that this brain region has a rigidly segmented organization, much like the body plan of insects and worms. To assist his research, he developed the Lumsden bioscissors. Most recently, he has focused on the developing forebrain, where he discovered signaling properties in a small set of cells that pattern the large surrounding region of the thalamus. Awards. Fellowship of the Royal Society. Elected 1994. The Academy of Medical Sciences, 1998, and King's College London, 1999. A membership of the European Molecular Biology Organisation, EMBO, 2008. In 2001, he was awarded the Royal Society's Prize for Neuroscience, the Ferrier Lecture, and in 2007, the W. Maxwell Cowan Prize for Outstanding Contributions in Developmental Neuroscience. Lumsden has also been elected Freeman of the Worshipful Company of Clockmakers in 2006 and as a member of the Athenaeum in 2015. Major publications. Lumsden Ag. Davies A.M. 1983. Earliest sensory nerve fibers are guided to peripheral targets by attractants other than nerve growth factor. Nature. 306. 5945. 786-8. DOI. 10.1038 306786 Say 0. PMID 6,656,880. Lumsden Ag. Davies A.M. 1986. Chemotropic effect of specific target epithelium in the developing mammalian nervous system. Nature. 323. 6088. 538-9. DOI. 10.1038 323,538 say 0. PMID 3,762,707. Tessier Levine M. Plachik M. Lumsden Ag. Dodd J. Jessel trademark. 1988. Chemotropic guidance of developing axons in the mammalian central nervous system. Nature. 336. 6201. 775-8. DOI. 10.1038 336,775 say 0. PMID 3,205,306. Lumsden A. March 1989. Multipotent cells in the avian neural crest. Trends Neurosci. 12. 3. 81-3. DOI. 10.1016 0166 2236. 89. 90,159-8. PMID 2,469,219. Lumsden A. Keynes R. February 1989. Segmental patterns of neuronal development in the chick hindbrain. Nature. 337. 6206. 424-8. DOI. 10.1038 337,424 say 0. PMID 2,644,541. Hefner C.D. Lumsden Ag. O'Leary D.D. January 1990. Target control of collateral extension and directional axon growth in the mammalian brain. Science. 247. 4939. 217-20. DOI. 10.1126. Science. 2,294,603. PMID 2,294,603. Fraser S. Keynes R. Lumsden A. March 1990. Segmentation in the chick embryo hindbrain is defined by cell lineage restrictions. Nature. 344. 6265. 431-5. DOI. 10.1038 344,431 say 0. PMID 2,320,110. Lumsden A. August 1990. The cellular basis of segmentation in the developing hindbrain. Trends Neurosci. 13. 8. 329-35. DOI. 10.1016 0166 2236. 90. 90144Y. PMID 1,699,318. Lumsden A. Sprawson N. Graham A. December 1991. Segmental origin and migration of neural crest cells in the hindbrain region of the chick embryo. Development. 113. 4. 1281-91. PMID 1,811,942. Guthrie S. Muchamore, Kuroda A. Marshall H. Krumloff R. Lumsden A. March 1992. Neuroectodermal autonomy of Hox 2.9 expression revealed by rhombomer transpositions. Nature. 356. 6365. 157-9. DOI. 10.1038 356,157 say 0. PMID 1,545,869. Simon H. Lumsden A. August 1993. Rhombomer-specific origin of the contralateral vestibuloacoustic efferent neurons and their migration across the embryonic midline. Neuron 11. 2. 209-20. DOI 10.1016 0896 6273 93 90179U. PMID 8,394,719. Lumsden A. Clark J.D. Keynes R. Fraser S. June 1994. Early phenotypic choices by neuronal precursors, revealed by clonal analysis of the chick embryo hindbrain. Development 120. 6. 1581-9. PMID 8,050,364. Graham A., Francis West P., Brickell P., Lumsden A. December 1994. The signaling molecule BMP4 mediates apoptosis in the rhombencephalic neural crest. Nature 372. 6507. 684-6. DOI 10.1038 372,684 say 0. PMID 7,990,961. Logan C. Wisenman A. Drescher U. Monschau B. Bonhoeffer F. Lumsden A. 1996. Rostral optic tectum adopts a caudal phenotype following ectopic engrailed expression. Current Biology 6. 8. 1006-1014. DOI 10.1016 S0960-9822 02 00645-0. PMID 8,805,331. Lumsden A. Krumlov R. 1996. Patterning the vertebrate neuraxis. Science 274. 5290. 1109-1115. DOI 10.1126. Science 274.5290.1109. PMID 8,895,453. Struder M. Lumsden A. Ariza McNaughton L. Bradley A. Krumlov R. 1996. Altered segmental identity and abnormal migration of motor neurons in mice lacking HOXB1. Nature 384. 6610. 630-634. DOI 10.1038 384,630 say 0. PMID 8,967,950. L.E. Wingate R. Lumsden A. 1999. Homeotic transformation of rhombomer identity following localized HOXB1 misexpression. Science 284. 5423. 2168-2171. DOI 10.1126. Science 284.5423.2168. PMID 10,381,880. CS1 maint. Multiple names. Authors list. Link. Fortin G. Youngbluth S. Lumsden A. Champagne at J. 1999. Segmental specification of GABAergic inhibition during development of hindbrain neural networks. Nature Neuroscience. 2. 10. 873-877. DOI 10.1038 13,170 seconds. PMID 10,491,606. Zeltzel, Larson C. Lumsden A. 2001. A new developmental compartment in the forebrain regulated by lunatic fringe. Nature Neuroscience. 4. 7. 683–684. DOI. 10.1038 89455. PMID 11426219. Larson C. Zeltzel. Lumsden A. 2001. Boundary Formation and Compartition in the Avian Diencephalon. Journal of Neuroscience. 21. 13. 4699-4711. PMID 11425897. Matsumoto K. Nishihara S. Kamimura M. Shiraishi T. Otoguro T. Uehara M. Mida Y. Augra K. Lumsden A. Augra T. 2004. The propattern transcription factor IRX2, a target of the FGF8 MAP kinase cascade, is involved in cerebellum formation. Nature Neuroscience. 7. 6. 605–612. DOI. 10.1038 NN 1249. PMID 15133517. Kayeka C. Lumsden A. 2004. Hedgehog signaling from the zona limitans intrathalamica regulates the emergence of thalamic and prethalamic identity. Nature Neuroscience. 7. 11. 1242–1249. DOI. 10.1038 NN 1338. PMID 15,494,730. Kayeka C. Lumsden A. 2005. Compartments and their boundaries in vertebrate brain development. Nature Reviews Neuroscience. 6. 7. 553–564. DOI. 10.1038 NRN 1702. PMID 15,959,467. Scholl PPS. Delogu A. Gilthorpe J. Pukert D. Lumsden A. 2009. HER6 regulates the neurogenetic gradient and neuronal identity in the thalamus. Proceedings of the National Academy of Sciences of the United States of America. 106. 47. 19895-19900. DOI. 10.1073, PNAS. 0910894106. PMC 2,775,703. PMID 19,903,880. Scholl PPS. Lumsden A. 2010. Building a Bridal Chamber. Development of the Thalamus. Trends in Neurosciences. 33. 8. 373–380. DOI. 10.1016, J. Tins. 2010.05.003. PMC 2,954,313. PMID 20,541,814. Delogu A. Sellers K. Zagorai OL. Boshanovska Z. Brog A. Mandel S. Gimira J. Rubenstein JL. Sugden D. Jessel T. Lumsden A. 2012. Subcortical visual shell nuclei targeted by iPRGCs developed from a SOX14 plus GABAergic progenitor and require SOX14 to regulate daily activity rhythms. Neuron. 75. 4. 648–662. DOI. 10.1016, J. Neuron. 2012.06.013. PMID 22,920,256. Gilthorpe J.D. Uzier F. Nash J. Calver M. Bennett D. L. Lumsden A. Pinney A. 2013. Extracellular histone H1 is neurotoxic and drives a pro-inflammatory response in microglia. F1000 Research. 2. 148. DOI. 10.12688, F1000 Research. 2 to 148. V1. PMC 3782347. PMID 24358859. Official page. YouTube clip talking about Neural Development Journal.